Today's video is the first video on linear equations. We will first talk about the forms of a linear equation. Slope-intercept form is the form that you probably used most in Algebra 1. Y equals mx plus b is the most common way that you see that, where m represents the slope of the linear equation and b represents the y-intercept of the linear equation. Point-slope form takes the form y minus y1 equals m times x minus x1, where once again m represents the slope, and then we have an ordered pair x1, y1 that represents some sort of point on the graph of the equation. Finally, we have standard form, and standard form takes the form ax plus by equals c, where a, b, and c are all integers. And some textbooks require a to be greater than 0 or a to be positive as long as a exists. As long as a is non-zero, they require it to be positive. However, I'm not necessarily nitpicky on that sort of thing. Special forms, for example, vertical and horizontal lines. Vertical lines take the form x equals some number, and then horizontal lines take the form y equals some number. So that is a special form. Y equals k is also the same thing as slope-intercept form, where m equals 0, or point-slope form, where m equals 0, because when you have a horizontal line, the slope is 0. However, a vertical line, x equals some number, that cannot ever be part of slope-intercept or point-slope form, because the slope of a vertical line is undefined. And so therefore, this form, x equals some number, x equals h, can only be related to standard form. Graph each of the following linear equations using at least 2 points. I will do these relatively quickly because these are all Algebra 1 topics. Y equals 3/4 x minus 2. This is in slope-intercept, so the slope is 3/4, and the y-intercept is -2. So I will start at the y-intercept -2, and then the slope is 3/4. So that means I'm going to change my y by 3 and my x by 4. And both of those are positive changes. Or I could make a -3 change in the y direction corresponding with a -4 change in the x direction. In either case, that works out well, and I have a graph of my line. Letter B is in standard form. So I have a variety of different ways I can do this. The first thing I'm going to do is to change it to slope-intercept form. So I will subtract 3x and then divide by 4. So I have 3/4 x minus 8, because 32 divided by -4 is -8. So I could change or manipulate the standard form of the equation to turn it into slope-intercept form. So I have a y-intercept of -8, and again, a slope of 3/4, where I go up 3 to the right 4, or I could go down 3 to the left 4. However, that will not really help me in this particular problem. I also could graph this using intercepts, and I should end up getting the exact same graph if I do that. The way to graph by intercepts is to make one of the variables 0 and find out where the intercept is of the other variable. So For example, if I make x equal to 0, that's essentially the same thing as covering it up, which I will often in class call that the cover up method. So if I cover up x, then I just divide by -4 and I get y equals -8, which indicates that 0, -8 is on the graph. Notice that that was the same thing that we found when we found the y-intercept. I can also find the x-intercept by covering up y or making y equal to 0. And then I solve by dividing by 3. So I get x equals 32 thirds. Um, and so I know that the x-intercept is 32 thirds, comma 0. 32 thirds is about 10 and 2/3, which, if you notice, is a point that's already on the graph. So I could have graphed it using intercepts, or what I call the cover-up method, if I wanted to do it that way. So that's problem 2. Problem 3 is in slope-intercept form, y equals x. If I need to do this, I could rewrite it as y equals 1x plus 0, just to visually see what's happening. So I have a y-intercept of 0 and a slope of 1. So the graph is going to look something like that. Um, I'm missing letter D for some reason on our worksheet. But letter E, y plus 4 equals 1/2 x minus 3. This is in point slope form. So my slope is 1/2. And my point, my ordered pair, is 3, -4. My ordered pair is 3, -4. Remember that in the formula for point slope form, there are minus signs that indicate that basically it's kind of a backwards um, type of thing. So if I see x minus 3, then the ordered pair 3, and then y plus 4 means -4. So that's kind of how that shows up. The reason why that works is if I substitute the point 3, -4 in for x and y. So if I substitute 3 in for x and -4 in for y, I will end up with 0 equals 1/2 times 0, and 0 always equals 0. So the reason why uh, it's kind of like a backwards thing, so to speak, is that I'm substituting 3 in where the x is and -4 in where the y is, and that will always make that 0 no matter what the numbers are. If I just flip whatever the numbers are, take the opposite, then that will always work. So that's why um, that sort of thing works. So I will take 3, -4, plot that on the graph, and then make my slope 1/2. And graph the line. X equals 8 is a vertical line at 8, and y equals -4 is a horizontal line at -4. So one thing that you should note about both of these problems is that if you struggle remembering which thing is horizontal and which thing is vertical, x equals 8, every single x value is going to be 8. This is the point 8, 0, 8, 1, 8, 2, 8, 3, 8, 4, 8, -9, and so on. All of the x values will be 8. That never changes. On this, all of the y values are -4, 0, -4, 3, -4, 7, -4, -10, -4. It does not matter. Wherever I put anything on that line, I will always have a y value of -4. Okay, answer the following questions and graph the equation. First thing we're going to do is we're going to graph the equation immediately because I want to practice a little bit more graphing from point slope form. So if I take a look at this, my slope is -3/2. We have not graphed anything with a negative slope yet, but it's not that complicated. It's an algebra 1 concept. The point on the graph is 6, -2. So I'm going to take 6, -2, plot that point, and then my slope is -3/2. So I can either go up 3 and to the left 2, or I can go down 3 and to the right 2, and that will represent a negative slope. Notice a negative slope, if you are running from, just pretend you're running from left to right, a negative slope is going to make you go down the hill. And if you're running from left to right, a positive slope will make you go up the hill. So those are things that you can kind of remember using slope. So that is the equation of the line. And I did not draw the line very well, but there it is. So this is a point slope equation of the line. Identify the point. Oh, we already did that. Identify the slope. Oh, we already did that. Transform the equation to slope-intercept form. Okay, now we can manipulate things a little bit. So if I start with y plus 2 equals negative 3 halves x minus 6, I'm going to use the distributive property. So I end up with y plus 2 equals negative 3 halves x plus 18 halves, which is the same thing as plus 9. Notice that a negative times a negative equals a positive in that particular case. So this is step 1. Now, all I need to do is subtract 2 from both sides, and I will end up with the slope-intercept form. So I have y equals negative 3 halves x plus 7. This is the slope-intercept form of the equation of the line. Notice that if I continue this graph, it should probably intersect at 0, 7, which is the y-intercept here. If I continue to go up 3 to the left 2, I will end up running into that point. Now I can transform this into standard form. All I have to do is add 3 halves x to both sides. So 3 halves x plus y equals 7. And then I have to remember the rules that a, b, and c all have to be integers. So the easiest way to make them all integers is, since there is um, a denominator of 2 here, I can just multiply the entire equation by 2, and I end up with 3x plus 2y equals 14, and that is a standard form equation. I also could have many other standard form equations of this with various multiplying effects. So 9x plus 6y equals 42 is also an equivalent form. It's just not as clean because the numbers are bigger. I can just keep multiplying and it all ends up being the same equation, just it's not the exact same uh, way to write the equation, but it ends up being the same line. Okay, find an equation of the line given the following information. Whew, okay, this is a little bit, it's not complicated, it just will take a little bit of time. Okay, through these 2 points, I'm going to use the slope formula. So the slope is y minus y over x minus x, and then I will use point slope form in order to find these things. So 2 minus negative 6 over 6 minus 3. So I'm just taking a y divided, or y minus a y, then an x minus an x. So that ends up being 8 over 3. That's my slope. And then I'll pick my favorite point. In this problem, it'll be 6, 2, just because I feel like it. So y minus 2 equals 8 thirds x minus 6. Through negative 6, 3, and parallel to 3x minus 9y equals 14. Okay, there are a lot of different ways I can do this. Probably the easiest way to do this is to, well, in my opinion, the easiest way to do this is keep 3x minus 9y and then figure out what c is after I substitute in 6 and negative 3. Because if I keep the 3x and 9y, I'm guaranteeing it to be parallel. So if I substitute in negative 6, I will end up with negative 18. And if I substitute in 3, I will end up with negative 27. So that ends up being negative 45 for C. So I could keep 3x minus 9y equals negative 45. But for many of you, it's probably easier to transform this into slope-intercept form. So negative 9y equals negative 3x plus 14. And then I divide, so I get y equals positive 3 ninths, or positive 1/3 x minus 14 ninths. But it doesn't really matter what this is, because that's going to end up being a different value anyway. So you can take y equals 1/3 x plus whatever the slope or the y-intercept is going to be, and substitute in, I'm sorry, substitute in um, these values and figure out what the y-intercept is going to be. So I substitute in -6 and 3, and I end up with 3 equals -2 plus b, so b equals 5. So I could also write this as y equals 1/3 x plus 5, which if I solved this, I would end up getting that exact same thing. And I just dropped my pen, so we're not going to use red the rest of the time we're doing video 1. Through -3/8 and perpendicular to y equals 1/4 x plus 5, notice or remember that perpendicular lines have opposite reciprocal slopes. So if two lines have opposite reciprocal slopes, that means I take the 1/4 and I transform it by flipping the numerator and denominator and changing the positive or negative. So 1/4 turns into -4. Just another quick example on the side. Let's say I had 2/3. The opposite reciprocal of 2/3 is -3/2. So I change the positive or negative value, and then I flip the numerator and denominator. So I'm going to have y equals -4x plus some y-intercept. I substitute in -3 and 8. So I have 8 equals 12 plus b, subtract 12, and I get b equals -4. So I end up with y equals -4x minus 4. Letter D, x-intercept of 3 and y-intercept of 5. That means I have 3 comma 0 and 0 comma -5 on my um, on my line. So what I can do is I can figure out the slope of that. -5 minus 0 over 0 minus 3. That's a slope of -5 over -3, or 5/3. So then I can just write y equals 5/3 x minus 5. The reason I can just put in -5 is it already told me what the y-intercept was. So slope-intercept form is really easy there. A vertical line through -2, 3 is going to be x equals -2, and a horizontal line through that point is going to be y equals 4. Remember, horizontal and vertical lines are just x equals and y equals, I'm sorry, verticals x equals and horizontals y equals. Then letter G, through 2, -1 with an x-intercept of 5. The easiest way to do that is probably to recognize that an x-intercept is just a point, 5 comma 0 in this case, and then 2 comma -1. So if I go 0 minus -1 over 5 minus 2, then I end up with 1/3 as my slope, and then I can choose either point to write the equation of the line. So y plus 1 equals 1/3 times x minus 2. And remember that this is a plus 1 because I basically take that -1 and put minus a -1, which turns into plus 1. And so that is the first video on linear equations.